Let's start to have a look at the distributive law. If we take x and then add 2 1s to it, we get x plus 2, which we can think of as one thing looking like this. X plus 2 is that one thing. Now, if we want 3 lots of that x plus 2, we want 1, 2, 3 of those x plus 2s. What's that going to be equal to? We'll focus on the yellow. We can see we've got 3 x's. Focus on the green, and we can see we've got plus 6 1s. So 3 multiplied by x plus 2 is 3x plus 6. And we can see that algebraically by just having a look here. We've got 3 lots of x plus 2. That 3 has to multiply with each and everything inside the bracket. So 3 needs to multiply with the x to give you the 3x, and 3 needs to multiply with the plus 2 to give you the plus 6. And that's the distributive law, that 3 needs to multiply with each and every term inside the bracket. So let's try a few more examples. 4 multiplied by x minus 1. The 4 needs to multiply with each term inside the bracket. So 4 needs to multiply with x, and you get 4x. 4 needs to multiply with minus 1 to give you minus 4. If you have minus 3x plus 2, we're going to do the same thing. But the thing I suggest you do before you start is just put a big warning sign for yourself next to that minus sign, because that minus has to multiply with each and every term inside the bracket along with the 3. So it's minus 3 times x, which is minus 3x, and minus 3 times plus 2, which is minus 6. One last example. Here again we've got a minus 3 outside the bracket, and it's got to multiply with each and every term inside the bracket. Again, I'm going to put a little warning sign for myself, so I remember that minus needs to multiply in with everything. Minus 3 times 5x is minus 15x, and minus 3 times minus 2, negative times negative gives me positive, so it is plus 6. Let's recap the exponent rule for multiplication. First, we remind ourselves where it comes from. If you've got b cubed multiplied by b squared, if we just write out what b cubed means, it means b times b times b. What does b squared mean? It means b times b. What does that come to altogether? Well, you see you've now got 1, 2, 3, 4, 5 b's all multiplied together, so you've got b to the 5. And so the rule is very easy to see alongside this, right? What you're seeing is when you've got b cubed multiplied by b squared, when you write it out like this, you'll see that you've got 3 b's here multiplied together, and then they're multiplied by a further 2, so you get b to the 3 plus 2, which is 5. So we can summarize that as follows. If we've got x to the power of p and we multiply it by x to the power of q, the rule says that we will have x to the p plus q. And again, easy to picture. This is p x's all multiplied together. This is q x's all multiplied together. So in total, we've got p plus q x's multiplied together. Let's have a look at how we'd apply this in an example. If we needed to do a calculation like this, we start by looking at each bit in turn. Let's start with the coefficients and multiply them together. We've got negative 3 multiplied by 2. That gives us negative 6. We then move on to our a's. So here we've got a to the 4 multiplied by a to the 3. And so we've got a to the 4 plus 3 just using our exponent law. And then we move on after that to our b's. And in this case we've got a b sitting over here which has got no exponent, but we know that that just means it's b to the power of 1. So we can apply the exponent rule here and we'll get b to the 1 plus 5. And now we can just finish up here saying it's negative 6, a to the 7, b to the 6. We're going to look at a few more examples using the distributive law. If you're asked to simplify this expression by expanding the brackets, what you need to do is multiply 4x by x minus 1. So 4x needs to multiply with x, which gives you 4x squared. And 4x needs to multiply with minus 1, which gives you minus 4x. If you're asked to simplify this by expanding, what you're going to first note is that negative, so that you remember that that negative also has to multiply with each term in the brackets. So you're then going to have negative 3x times x, which is negative 3x squared, and then negative 3x times 2y, which is going to give you negative 3 times plus 2 is negative 6, so it'll give you negative 6xy. And then something like this one, again take note of the negative, and first you will multiply negative 3x squared with 5x, so negative 3 times 5 is negative 15, and x squared times x is x cubed. And then you'll multiply negative 3x with negative 2. Negative times negative is positive, 3 times 2 is 6, and so you'll have plus 6x squared. One small point I want you to note is that when we're doing this expanding using the distributive law, what we have is something outside the bracket, and then inside the bracket we have two terms that are separated either by a plus or it could be by a minus. So that is when you use the distributive law. If you have something like this, where inside the brackets you've got a multiplication, you don't use the distributive law. Because the brackets, when you've just got minus 3x and then the brackets, it's just multiplication. And so really what you've got here is all these things multiplied with each other. So it's minus 3x times x times 2y. No distributive law being used here at all. And this will sort out to minus 3 times 2 is minus 6. X times x is x squared. So you've got minus 6x squared y. The main point I wanted to make here is you use the distributive law when you're multiplying into a bracket where you've got addition or subtraction of terms. We're going to look at some examples where we expand brackets using the distributive law and then simplify by combining like terms. So if we were asked to simplify something like this, what we first need to do is multiply out the brackets, and we know we're going to need to use the distributive law here and here in order to do that. So let's go ahead and do it. 4x times x is 4x squared. 4x times minus 1 is minus 4x. Plus 3 times x is plus 3x, and plus 3 times plus 2 is plus 6. Now we're in a position where we just are adding and subtracting terms, and in algebra when we're just adding and subtracting we need to look for like terms. So the like terms here are minus 4x and plus 3x because those terms just have an x in them. The x squared term doesn't have a like term to go with because there's no other x squared term, and the number 6 doesn't have a like term to go with because there's no other plain number. So when we simplify, the 4x squared is going to stay there. Then minus 4x plus 3x is minus x, and then the plus 6 is just going to stay there. Another example like this, if we're asked to simplify this one, again, we're going to use the distributive law to multiply out each of the brackets. But the one thing we're going to be very careful about here is to make careful note of these minus signs. So I suggest putting a big fat red arrow there so that you don't forget the minus signs, because it's very easy to slip up with them. So let's then go. Minus 3 times x is minus 3x. Minus 3 times plus 2 is minus 6. Minus 2 times 5x is minus 10x. And now this next point is the point where people often forget the minus. Minus 2 times minus 4 is plus 8. Now we need to look for like terms because we're just adding and subtracting in algebra. So minus 3x and minus 10x are like terms, and minus 6 and plus 8 are. So we're going to get minus 3x minus 10x, that's minus 13x, and minus 6 plus 8 is plus 2. Let's do a quick recap of the exponent law for division. If we're asked to look at 3 to the 6 divided by 3 to the 2, the first thing we need to remember is that division can always be rewritten as a fraction. And then when we're dealing with exponents, a useful thing to do is to write out what the exponent actually means. So 3 to the 6 is 3 multiplied together 6 times, and 3 squared is just 3 times 3. Now it's quite easy to see that these two at the bottom, these two 3's at the bottom, will cancel with 2 of the 3's from the top. And so instead of having 6 3's at the top, you've got 2 less now, so you've got 3 to the power of 4, and 3 to the power of 4 you can actually work out. 3 times 3 is 9, times 3 is 27, and times 3 again is 81. And if we were to work with letters, the same thing would apply. If we've got p to the 5 divided by p to the 3, we're going to then write it out. P to the 5 just means you've got 5 p's multiplied together, p to the 3, 3 p's multiplied together. And then the 3 p's at the bottom will cancel with 3 of the p's at the top, and that will leave you with p times p, which is p squared. Now notice here, because it's going to help us find a shortcut for doing this, you had at the top 5 p's multiplied together, and you had at the bottom, you had 3 p's multiplied together. Well, can you see that the 3 of these p's are going to take out 3 of those 5 p's, and so what you are left with is 5 minus 3, which is 2 p's. Let's look at another example. If we had b to the 7 over b squared, what you've got here is at the top you've got 7 b's multiplied together, and at the bottom you've got 2 b's multiplied together. And what's going to happen is that these 2 b's at the bottom will take out 2 of the b's at the top. So what you're going to be left with is just 7 minus 2, which is 5 b's multiplied together, which is b to the power of 5. Now if we combine letters and numbers, the division is still easy. All we need to do is look at each of them separately. So if you have a look here, you've got a 20 at the top and a 4 at the bottom. Those are the numbers. So let's divide. 20 divided by 4, nice and easy, is 5. Now let's look at our exponents here. We've got x cubed over x squared. So we're going to have x to the 3 minus 2, which is x to the 1, which of course is just written as x. If we look at this one, let's look at the numbers first. Negative 6 divided by negative 2, that is just 3. And then we move to the exponents. We've got 6 p's multiplied together divided by 2 p's multiplied together. So we're going to have p to the 6 minus 2. So it's going to be p to the power of 4. Let's have a look at the distributive law and division. If we're asked to simplify something like 6x plus 2 over 2, one way we can think about it is to think that dividing by 2 is just the same as multiplying by a half. And so what we've got is half times 6x plus 2. This means we can just use the distributive law we've always been using. Half times 6x gives me 3x, and a half times plus 2 gives me plus 1. So what we're seeing is that when we've got 6x plus 2 over 2, we're going to distribute in the same way. We're going to have 2 dividing into the 6x as well as 2 dividing into the plus 2. So division works just like multiplication in this regard. So we can go through it in a short way without having to go through multiplication and just say the 2 needs to divide into the 6x, and that gives us 3x, and the 2 needs to divide into the plus 2 and give us plus 1. So this is how we use the distributive law when we're working with division. It works in the same way that multiplication worked. And that makes sense because multiplication and division are closely related to each other. So let's have a look at a more revolting example. If we were asked to simplify something like this, well, again, we just need to make sure that that negative 3x squared at the bottom divides into each and every piece at the top, each and every term at the top. So negative 3x squared must divide into 6x cubed. 6 divided by negative 3 gives me negative 2, and x cubed over x squared is just x. So I've got negative 2x. Then I need to divide minus 9x squared by minus 3x squared. Negative divided by negative gives me positive, 9 divided by 3 gives me 3, and x squared over x squared gives me 1, so I've got plus 3. So this is the distributive law for division. It's very important to remember this distributive law for division, that the term at the bottom needs to divide into each and every term at the top of the fraction. Because it's very tempting when you're faced with something like this to say, oh, let me cancel the 3 with the 3 and say the answer is 2x. But this is wrong, because that 3 at the bottom should have cancelled with each and every term on the top. So we can't do it like this. What we'd have to do instead is to say the 3 must divide into the 3. That gives me 1. And then I've got the 3 dividing into the 2x. That's not going to work out very neatly, but that's fine. I can just write it as plus 2x over 3. The important thing to see here is that 3 at the bottom divides into each term at the top. So if you see a fraction where in the top, the numerator, you've got things added together or subtracted from each other, remember that the denominator must divide into each and every one of those terms. The story with multiplication is different. If the two things at the top are multiplied together, and again, multiplication and division are closely related. So here you haven't got different terms at the top that are added or subtracted from each other. Here you can cancel with the 3 and be left with 2x. No problem if you're multiplying. But if your numerator has adding or subtracting, you must use the distributive law. I'm going to have a look at a past exam question on algebraic expressions. Okay, let's do these. If you are able to, I'd suggest you pause the video now and try these on your own, and then as we go over them, you can see whether you've got it right or wrong. 5.1.1. What we need to do here is we are subtracting a negative, so that's the same as adding. And if we add here, we will get minus 5b. Okay, this next one we're squaring, and we're squaring everything inside the bracket. So we need to do negative 3 squared, which is negative 3 times negative 3, which is 9. And a cubed squared will be a to the 3 times 2, which is 6, using our exponent laws. But if your exponent laws confuse you, remember you can always just write out what this thing actually means. So because we're squaring the bracket, it just means the bracket times the bracket. And then that's easy. Negative 3 times negative 3 gives you the 9. Here you've got a cubed, which is a times a times a, so 3 a's multiplied together. And then you've got another 3 a's multiplied together. And so in total, you've got 6 a's multiplied together. So the little saying, if in doubt, write it out, is very useful for exponents. Okay, in this next one we've got multiplication and addition. So using our BODMAS, BEDMAS, whatever you want to call it, our order of operations tells us we must do the multiplying before we do the adding. So here we have 3 times 2 is 6, and p times p squared is going to be p cubed. And then 3 times 6 is 18, and p cubed times p squared is p to the 5. Okay, The next one, we're doing a division. So let's go through it step by step. Firstly, we'll do the numbers. So 2 divides into 8 4 times. Then the x's, we've got an x squared over an x. So we've got an x times x over an x. So this x will take care of one of the x's up here, leaving you with just an x. And then y to the 5 over y to the 10. Well, 5 of these y's will cancel with 5 of the y's down here, leaving you with y to the 5. So what we're left with is 1x, which we can just write as x, and 4y to the 5, like that. Now, if that seemed confusing, remember with exponents, if in doubt, write it out. So let's do that. Okay, so here I've written it out, right? X squared is x times x, y to the 5, y times y times y times y times y, etc. So once I've written it all out, it's very easy for me to see how it all cancels nicely. This 2 will cancel with the 8, leaving you with 4, this x with this x, and then these 5 y's with 1, 2, 3, 4, 5 y's on the bottom. So what are you left with at the top? An x. And what are you left with at the bottom? A 4 and y to the power of 5. Okay, for this one, I obviously need to use my distributive law. And the one thing I'm going to do is just put a big circle around that negative because it's very easy to forget it and then get things wrong. 6 times 2, 12x. 6 times negative 5 is negative 30, so I've got negative 30y. Now negative 2 times 3x is negative 6x, and negative 2 times y is negative 2y. And now I'm just adding or subtracting, and so I need to look for my like terms. And then I get 12x minus 6x is 6x, and minus 30 minus 2y is minus 32y. Okay, for this one, again, I've got to use my distributive law. So let me go ahead and write it out. This 3p cubed has to be divided by the 2p squared, and then the 6p squared also has to be divided by the 2p squared. This will cancel with that, leaving with p. Here, p squared cancels with p squared, 2 cancels with 6, leaving 3. And so what you're left with is 3p over 2 minus 3.